All right, so today we're going to talk about circuits, okay? And circuits are everywhere. You use them every day, all the time. A lot of you probably don't even realize you're using it most of the time because a lot of it is hidden from you. For example, the lights that are up here, right here, those lights are a part of a circuit. It actually goes from the power plant. The electricity flows through the power lines into the building, gets separated out in the building, ends up in here, and then actually goes back to the power plant too. Because a circuit is a closed path through which current can flow. We talked about how it flows from high potential to low potential already. And the electrons flow in the opposite direction, but it needs to be a full loop, okay? Let me show you kind of what I mean by that. I have this battery hooked up directly to this bulb, and you'd think that the bulb would be lit up, right? But unfortunately, it isn't, because even though there is no path back to the battery, you need a path back to the battery in order for there to be a full circuit, okay? So you see how as soon as I give it a path back to the battery, it has to be a complete loop, okay? Let me give you another visual of that, and just give me 1 second. I forgot one little piece that I forgot. All right, I need you guys' help real quick. Do this for me. If you guys could all stand up real quick and kind of join me. And we're going to make a big circle kind of awkwardly around these two tables, we'll call it, okay? Yes, we are. So if you guys wouldn't mind, don't be weird about it. It's not that weird. And I want everybody to hold hands if possible, okay? All right, go ahead and come over here. Hold hands. Hold hands. Hold hands. Okay, I'm going to go ahead and insert myself over here because we've got, can you bring it in a little tighter? Guys, stop playing. Come on. Seriously, guys. There you go.
We're waiting on you.
Let's go. Come on. Come on. There you go, right here. All right, so if you look real quick, you guys are a complete path, okay? You got to make sure you hold on tight. I know, don't be weird about it. It's totally okay to touch somebody else's hand. All right, so what I'm going to do is I'm going to insert myself over here. All right, and what I'll do is we'll break it right here, and here's what I'm going to ask you to do. You're going to touch this terminal of the battery with just one little finger, and then you're going to touch this terminal of the battery with one finger. All right, now what I want you to do is hang on tight. All right, I want you guys to let go. Now I want you to grab on again. All right, now I want you guys to let go. Grab on again. You guys let go. Grab on and tap, tap, tap. Tap, tap, tap. Okay? So you guys right now, you guys are a circuit. And if there's a break anywhere along the way, then it's not going to work. We call that an open circuit, okay? This is a closed circuit. And because of the closed circuit, if we have a break anywhere in the circuit, let go, then it will not. You guys are the circuit in this spot. Yeah.
Whoa,
exactly.
What is it? Hold on, explain yourself. What is going through us?
Electricity.
No.
Yeah, they have the positive.
But it's also
I think so. So if you... All right. So, ladies and gentlemen, what we do is, that was what we call a closed circuit. And a closed circuit electricity can flow. Any break along the way, and there's an open circuit electricity can't flow. That's why when a power line goes out in your neighborhood, most of the power goes out to the whole neighborhood, because you lose the closed loop back that goes back to the power plant. Now, what we do, what scientists do, is they make what they call circuit diagrams. And I'll give you an example of a circuit diagram that you might see, okay? This is an example of a circuit diagram that is, this is a circuit diagram for a radio, okay? So it's a pretty simple device, but you can see how complicated even a simple device can be. The people that design these systems are called, anybody know? Electrical engineers, okay? So if you wanted to go to college and study electrical engineering, this is the type of thing that you would do. You design circuits. You design ways to make electricity flow in different ways. And you do that using different things. Now, this is a little bit more of a complicated version of it, but I want to show you, we're going to use a much simpler version of it. We're going to use basic circuit diagrams with basic boards, okay? But I want you to be able to read the circuit, build that circuit, and then sort of, be able to understand what you're looking at. So current flow requires some kind of thing, a battery or a voltage source. There's a voltage source would be a plug on the wall. It could also be a battery like this. You guys, most of your devices use lithium-ion batteries these days, right? Or say, for example, your calculator. How many batteries does it have in it? 3. It has 4. It is 4. Does anybody know how much the battery, how much voltage is supplied by each one of those batteries? So a AAA battery is 1.5 volts. A AA battery is 1.5 volts. A C battery is 1.5 volts. A D battery is 1.5 volts. So they all supply 1.5 volts. Okay. In addition to that, we've got devices like smoke detectors that usually use what type of battery? The square one. What's the square one? It's a 9-volt battery, so that would supply 9 volts. Most batteries supply 1.5. If you have 4 1.5 batteries, how much voltage does your calculator need?
1.5 times 4.
You guys are wicked smart at math. Okay, 6 volts. Good job. Okay, now, what we do to represent batteries in circuits, and we often call that voltage, we call it potential difference, just FYI. But we call a single cell battery would just have one line, and a double cell battery would actually look like that, okay? So you'll see a little bit of both of those. We're just going to use that for all our batteries. Notice 2 things I want you to be aware of, because you're going to need to draw them correctly. You need to have one end of the battery longer than the other. You see that? Those 2 plates are not the same length. If they were the same length, they would be something different, okay? So you need to draw these so they are the same, different lengths. And you have a little positive on the long one and a negative on the short one, okay? So be aware of that. In addition to that, you might have what we call a switch. And a switch, what it does is it allows you to determine, without pulling out a wire, it allows you to break the circuit if you choose to do so, okay? And let me see if I can find a switch for this real quick. There's one. This is a switch. You'll notice that it goes up like that, and then it goes down like that, and then it goes up like that, and it goes down like that. What it is it's just an easy way, without having to pull out a wire, of actually turning off the circuit and turning on the circuit. And it is absolutely no different than this little switch that we have right here, okay? What it does is it's a conductor that if you put it open, it creates an open circuit, and if you put it closed, creates a closed circuit, okay? Now, over the course of the next couple classes, And we won't have a quiz next class. We will have a quiz the class after that. But what we're going to talk about is we're going to talk in depth about voltage and how to measure it. And so we use what we call a voltmeter to measure voltage. And you'll see a V in a circle as a circuit diagram representation of a voltmeter. And I'll show you that we're going to use these voltmeters to measure the voltage of batteries in the next few days, okay? And a voltmeter looks like this, okay? And this is actually what we call a multimeter, because back in the day, they needed two separate devices, a voltmeter and an ammeter. But now we've gotten so fancy that there's one device called a multimeter, which does both, okay? So, and we'll be using these a lot, okay? So a voltmeter, the thing that measures current, and that's what we're going to do next class, is called an ammeter, which is really just a multimeter. There's these little things that have little squiggly lines like that. That is called a resistor. And what a resistor is it resists the flow of electrons. When it does that, it converts some energy from electrical energy into some other form of energy. An example would be the top of a light bulb. On a light bulb, in the light bulb, there's a little piece of wire, and then there's a little curly Q, and then it goes back down in, okay? This little curly Q is a thing. It's called tungsten, okay? It's made out of tungsten. And it is a resistor that when you let electrons through it, it resists the flow of electrons. And when it does that, it glows and it gives us light, okay? It also gives us some heat too, okay? Which some of the energy is lost to heat, some is lost to light. But we want it to glow, okay? So that's how we get light. This is called a variable resistor, and we use variable resistors all the time in real life, and you guys probably don't even realize it, okay? All it is a little knob like this, okay? And you'll see it's just a little knob, but when I put it in the circuit, what it essentially does is it allows me to vary and control the amount of electricity that's flowing in the circuit, okay? So this is just like what in your house? The dimmer switch, okay? But there's a lot more of these than you realize. So when you turn on your stove, you do this, don't you? Right. And what are you doing when you turn on your stove? Well,
You're igniting. Make it more hot.
You're making it more hot. Well, what it is that little coil on the stovetop, if you have an electric stove, is a resistor. And when you run electricity through it, if you turn it up real high, it'll glow like crazy and it'll get hot, 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 hot because it's resisting the flow of electrons. But then if you want to turn it down nice and low, it won't do it so much. So this knob gives you a little ability to adjust the flow of electrons. So that comes in the form of some basics. And things like volume switches are variable resistors, okay? And then there's a lamp, which you'll see there's a little curly Q inside of a circle. A lot of times, they're actually represented these days. You'll see them drawn like this. You have an X like that, okay? And so that is, it's really just a light bulb, okay? And so if you want to put a light bulb, but what is a light bulb really? A resistor, okay? So technically, this should really just look like that, but they have a different symbol for that, okay? We talked about open and closed circuits, and we did our little demo, so you guys understand it. So today is really just what I call a discovery lab. Essentially, what you're going to be doing is I'm going to be sicking you on just, here's a box full of awesome stuff.
Oh, that sounds
And here's what I want you to do. I want you to build the circuits that are diagrammed in that packet, okay? So each group, I'm gonna hand a box full of stuff. And what you're gonna do is you're gonna build the circuits that I'm asking for, okay? All right.